Ah, draft physics video. Yay. Yeah, I think a half day response probably. If I can remember. Outside shoveling and stuff. Anyway, so just first thing I'll show is just this polarized film thing. Just a little quickie on that. You should be able to see this, I think. Anyway, so there's the beam where the light's the brightest. Now, if I turn the film 90 degrees, well, I don't know if you can see that. Gee, that's not doing the same thing it was doing a minute ago. It has a lot less flare, number one, but obviously you can see that brightness is a lot brighter there. And there seems to be a lot of, whatever you want to call that diffraction stuff. So it's not a, this isn't a lens artifact. The other thing was a lens artifact, but this isn't. And you can just see that it almost goes down to, it's like half, less than half. So it is just kind of funny that some of the light is not, I don't know what the right word is, right? It's polarized in two directions. I don't know. I mean, quite obviously there's a difference, so that's all I mean. The laser pointer isn't very precise, and obviously this film is kind of funky, but you get an interference pattern going both ways there, which is kind of interesting. Just going through the filter. So that's all it's doing is going through this filter. So you can sort of here, you can probably see that. So all I did was turn the filter, and it's get the light through there, and just turn it the 90 degrees. So there, it's one intensity. Oops, in there it's much less intense. Probably can't see the target, but it doesn't matter. But that's all I was doing, just from 90 to 90. Anyway, yeah. So that's probably enough of the experimenting part. Just curious that the laser pointer is polarized. The film, I guess I could show you that if I put two pieces together, it goes all the way dark and blah blah blah. But whatever. So it's it's old film, but it's the problem is that it's really thick. The stuff I have is thick, and it's got a little bit of a bend in it too, which just makes it a little difficult to work with. So yeah, I can't really do eraser experiments precisely enough. Anyway, I can't do them with this source. This light source is already messed up. So alright, so you brought up the shape thing again. I just don't see how it's terribly important with the shape of the light is that it ends up being filterable. I mean, the fact that it has a shape, right? So you just take a ball and you compress it into a disc. What's the difference? I don't know what its shape is. There's no way I can deduce that. I can only speculate on it. I can just guess. I'll say diamond shape. I'll say this. I'll say it. Just doesn't matter. The argument would just be is that there is apparently a shape. So what? I mean, it's not really. I mean, part of my argument is that when photons, gravitons, when these tons are arranged inside of matter, that has mass, that they are fitting together. That they are doing some sort of thing where they're bound to each other. Not bound by any force, but bound by like a physical connection. So I would argue that they probably do have a shape. So I can just make them into arrowheads or something. I can make them into lots of shapes that would create an idea of bounding. I could also just make them an S shape and just say they hook on each other. Two hooks, and just say they hook on each other. There's lots of mechanisms you can come up with to say, okay, that's the shape of them, and that's how they can get have their frequency reduced, and that's why matter can hold so much energy. It's because the energy is compressed, because the energy binds to itself, binds to each other. And that's the difference between matter and not matter, is this binding element. Anyway, that would be my speculation on that. So then, on the conversation of, I guess I'll just do the entanglement thing. The idea of this idea of faster than the speed of light communication seems to me to be a non-starter, because it just seems a contrivance of voodoo almost. that, oh, somehow it doesn't leak into reality. Somehow you have faster than light communication and it doesn't leak into reality. There's no way for that communication to have an impact on anything where we could perceive the communication. Yeah, and it just seems like, it's like the old dodge that, somebody's psychic, and you ask them, well, why can't you pick lottery numbers? And there's like, oh, there's a rule, I can't win the lottery with my psychic powers. Oh, how convenient. So I would argue that there is no instantaneous communication anywhere in the universe. The speed of light seems to be a really durable constant. And the fact that it's the same speed, the speed of light is the same speed of all these forces, magnetism, electricity, and gravity. They all move at the speed of light. I think that should say, hey, you know what? Maybe they're made out of the same stuff that light's made out of. I just don't think that's reaching too far. And again, so you're not really arguing my theory, so I don't know, you can talk about this stuff all you want. I'm not, I'm just saying I don't know how it's really relevant to what I'm saying, because you're just not acknowledging my argument. And my argument is that light has no character, photons have no character, that it's just been a misperception of what a photon is. And a photon, what it really is a pair of tons, quanta, and that their frequency and the wavelength is a manifestation of the distance, the period between them, their arrival time. And so there has to be more than one for us to perceive it. And that we have to, to perceive most things, we have to tune, like radio, we have to tune to the frequency. We can't see it unless we tune to it. It's that kind of thing. And matter is intrinsically tuned to the frequency of light. A lot of matter. And so that's why it's more obvious. But it's clearly tuning. Okay, clearly some matter reacts to ultraviolet light, some matter reacts to infrared light, some matter is transparent to one and opaque to the other. Like glass, for example, is, it's opaque to ultraviolet light. I mean, these are just things that are very, these are just facts. That certain light doesn't go through certain kinds of matter, because the tuning of the electrons are tuning it out. They're only vulnerable to certain frequencies, certain types, certain interactions. All right, so anyway, yeah, I don't think the entanglement's ever been proven in any real experiment that doesn't have too many places where they're screwing with it. Just the very idea that you're bouncing light off of a mirror, you're already in trouble, because theoretically it can't be bounced off a mirror. You brought up polishing glass as and Feynman. I don't think Feynman's argument wasn't that the fact that you can polish glass removes the fact of that glass has a structure. I mean, it's just talking about getting rid of defects that might be responsible for something. But polishing glass does not change whether or not it's going to be reflective, or in the sense that once the light gets through the glass. So yes, it can change the reflectivity. You can scatter, through having glass that has a uneven surface. An unpolished glass, you can create more refraction, more scatter. But the point is, we're talking about experiments with polished glass. I mean, glass that's as clean as possible. When we're talking about the quantum effects regarding glass. Let's see. So I mean, it's never purely, 100% transparent. It's a tricky thing to create. I mean, that's that certain perfect thickness where you get no reflectivity. And then the maximum reflectivity, but it's only for a specific wavelength of light again, which is the catch, right? Every wavelength has a different thickness of glass that it's 100% transparent to. So, it's theoretically of little value in some sense. I mean, it has a general effect. I mean, they actually apparently do this for submarines, where they, create glass that's just the right thickness to take advantage of the lowest reflectivity. But the point is it's still, as long as there's white light coming, multicolored light going through the glass, you're still in some trouble in the sense that the thickness to get that perfect no reflectivity is only going to work for one wavelength at a time. Each thickness has a different wavelength. So anyway, but that's a subject. I didn't really want to get into that. I just want to get into the force part of it. So that's the big argument to me. So, the shape of photons or gravitons to me is not terribly relevant. I think the important point is that all these forces are the same forces. So right down to the nuclear force, as I said before. And I guess I'll just use that as an example again. Just do it one more time. Alright, so you got a proton, a neutron, and an electron. And the argument sort of being made here is that when gravity goes through all these things, and so this is the smallest scale, but let's say it's a 1,000,000 to 1 scale. Okay, so for a million density of a particle, there's, that's how many of, so there's still, it's still a highly, it's a lot more noisy in the sense that things get bounced around because these are like real meteors now. Gravity is like a real meteor to say a proton or an electron. But you'd still be saying it's some kind of like 1,000,000 to 1 or 10 million to 1 or billion to 1 ratio between the size. But the point is that there is this constant bombardment. So you could almost think of it as rain. So it's like rain is always hitting from all directions on these particles. And that what happens is that these particles, like a piece of polarized film, what did I do with it? Who knows? They change. So the graviton goes in one way and it comes out with a different polarization. And that different polarizations have different effects on the receiving matter. So a proton could be sensitive to, again, the plus, and then neutrons could be sensitive to the minus, and electrons could be sensitive to something in between, the middle polarization. So you have that 90, 45, 90 thing. You have that 45 tricky angle in between. And you could almost argue that those are the two polarizations, 45 to 90 and then 45 to 0. And one would be responsible for electricity and the other one's responsible for what's called magnetism. Something like that. Or the inverse could be that magnetism is the scale all the way down, plus to this degree, complete polarization, and that electricity is that middle polarization. But the point would be is that through this effect you create a flavor. So you have like an A, a B, and a C kind of graviton that comes out. So a graviton goes in, affects the body in a certain way, mass, and then it expels the graviton at a specific flavor, A, B, or C. And then each kind of atomic particle would have a different sensitivity to these different components. So depending on, like I said, the proton could be expelling all B's, and then the electron is sensitive to B's, or invisible to B's, but it sees C's. So the neutron's creating C's. So C's are coming from the neutron, B's are coming from the proton. So one force ends up being attractive in the sense that it's invisible to the B's, so they go right past it, which causes the electron to move towards it because it's receiving the gravity pressure, which has lots of A's in it. So it's getting hit with A pressure. It has no compensating A coming back at it because all the A's from this side are getting converted into B's by the proton. So you can sort of just, as a I know this is a little sloppy, but I'm just saying the A's come in, they get converted into B's, the B's are invisible to the electron, and so it's still getting the A pressure hitting it from this side, no A pressure coming from the proton going through it, so obviously there would be an attractive force, and the repulsive force would be just the opposite, where all the C's in the gravity are converted into A's, and the proton is really sensitive. I mean, the electron is really sensitive to the A's, and so now that would be a pushing away force, because it's creating extra density of the thing it's sensitive to. And taken to the bigger world, this explains magnetism and electricity, and then ultimately it explains gravity. It's just that in gravity, it's the most invisible, in the sense that the resolution is so fine, you know, the amount versus mass, and then and on this level it's a much grainier, sandy environment. The raindrops are just so small that we can't orient ourselves to the idea that we're being hit by a rain of gravitons, because they're only raindrops on the nuclear scale. On the nuclear scale, they're only little raindrops. From our scale, they're even smaller. I'd say they're probably bigger than a raindrop, just because obviously photons and electrons interact rather aggressively. And so you would think that the photon compared to the electron has to have some kind of substance. But again, that's more of an argument for their frequency than polarization, I would argue. The dynamic of frequency just happens to be that the dynamic of how the equal and opposite reaction kind of thing. And if the photons they're coming in fast enough, there's no reaction fast enough, and therefore tipping point kind of argument, that the force is increased based on the effect of the force is increased based on how quickly the force is applied, the frequency of the force. So again, I guess I would argue that your characterization of my argument of the two-slit experiment was a little bit, I mean, it's not terrible, but I guess I'll just, for clarity, I'll say that what I'm arguing is that there's lots of photons hitting these surfaces. Okay, the ones that go through, but there's lots of photons hitting these surfaces. And what I'm arguing is that bigger surfaces obviously can't be vibrated as aggressively. They spread, the force gets spread out of the impacts of the photons that get absorbed. And the ones, then this little impediment in the middle has less capacity to absorb, the effect, because it has to do it electrically, right? It has to go electrically through the material this way. It has to migrate through it, where in this other stuff it just has this big damping field. So this field is harder to damp. So I guess, and what I'm so arguing is that it's not so much the material itself is vibrating. See, that's where you start bringing up the polishing argument. I'm not saying that it's just the fact that the atoms are sitting at the surface in some sort of arrangement where the electrons are facing the photon, like it's a photon, this surface, right? The slit material. The surface has an atomic structure, right? An arrangement of the atoms, and one assumes the arrangement is sort of consistent. So the atoms themselves are vibrating, but what I think we also know is that around all matter is a field. A static electric field, if nothing else, that it probably carries some, and that field is probably captured some number of ions in something outside of a vacuum. So I suppose, I know they've done the experiment with electrons in a vacuum, but I wonder if they've done the two-slit experiment with photons in a vacuum, because that might be an interesting way to see. Not that a vacuum would get rid of these extra ions, because you can't necessarily create a vacuum that perfect, but it certainly would reduce the effect if you could take out as much of this particulate matter as possible that could arrange itself on those field lines. But again, my argument is that photons only react with matter, and so there is no such thing as gravitational lensing. It's only an incidental arrangement, that in close to bodies and gravity you have strong magnetic and electric fields, and those fields will trap a high density of charged particles, ions and such, where there'd be lots of electrons available for diffracting light. And so that's what's diffracting the light, is the density of particles trapped in the fields around the matter. Because as the gravitons, let's say the gravitons go in, the gravitons are coming out. Okay, they're coming out. And that's what creates these fields. These electric fields are being created, okay, by energy going out. So that's why when there's a field line, when you have a field, all the field is being a representation of is that there's a proportional intensity of stuff coming out of it, so that the perpendicular to this point. And so that what it's basically saying is that, so if this is a shaped thing and it has a field going around it, the point is that the field, the photons, the gravitons coming out at all these different angles converge at this point, and that this perpendicular to that point is where something would be pushed by the net field strength from all these points. So the infinite number of possible gravitons coming off the surface have the net effect of a perpendicular release from this field line, and that essentially establishes the existence of field lines. Field lines aren't a real thing, they're just a convergence of a mathematical point where there's always a perpendicular release. If something has no energy and it's placed on that point, that's the direction it would head off in. That's the neutral. It doesn't head off in that direction because it's a perfectly balanced position, but the point is, if it had any velocity, its velocity would be perpendicular to those field lines. It's sort of a complex subject, so I don't want to get too deep into that. So anyway, so yeah, I mean, you keep saying, I mean, you keep just seeing, you know, like I said, I don't know what to say about this whole idea of you being obsessed with what I consider to be the stuff that just doesn't matter. I mean, the shape of the gravitons is just, who cares? Theoretically, polarization might have something to do with the lag time. Well, I don't think I want to even go there. You know, because then it just gets more complicated for gravity. So never mind that part. But let's just say it's a shape, and depending on that shape, you know, different matter will react differently depending on what shape is coming at it. And I would argue that that shape is sort of dependent on what everything is aligning to, which would be the fields that it exists in, the relative fields it exists in. They're always going to realign to those fields. So that's why there's a coherency between the directions. So even if I turn a magnet, it's still equally magnetic in all directions, because all the matter is equal, you know, is being reoriented to the all the relevant particles are constantly gyroscopically oriented to the field being created by gravity. Yeah. And gravity has a potentially infinite impact, but obviously as a practical matter, there's a range of its force effectiveness. But what little amount of force you need to move an atom. You know, you probably don't need much of a force to turn an atom. Anyway. So is there anything else I got to get to? No, but I mean, quite obviously this does it, you know, this solves the Feynman problem, in my opinion, because, yeah, I don't need a rubber band, I don't need anything. You know, it's all explainable as merely being flavors of photons, and depending on the flavor, the polarization, different matter is going to be affected differently by these quanta of gravitons. I don't know how we do this this modification of the language. So we better understand that photons aren't photons. Photons are made of something. The thing they're made of is being called photons. You know, that kind of thing. I don't know. I don't know how to fix that. I guess I could just call them all gravitons and just say a photon is made out of gravitons. 2 gravitons with a wavelength. And is there something else I need to say? Something else I gotta get to in your video? Yeah, no, I think that, but I'm just saying this provides a purely mechanical explanation for all the forces, and it does so completely consistent with the idea that the forces move with the speed of light, and completely consistent with it seems that everything has this inverse square rule, this, as I have the distance, I quadruple the force, which is, you know, the size, you know, half the distance, 4 times the blocking power, you know, and that's consistent with all these forces, and that's consistent with it being created by particles of a shape that I don't think needs description at this point. So anyway, yeah, it's probably enough. Yeah, for this episode anyway. You know, we'll get to more things as more things are necessary. But yeah, I don't know what to say. I mean, your videos, you know, frankly, sometimes your videos, I can't tell what you ought to be more explicit. I mean, you ponder questions as if they're, oh, you know, you're expecting somebody to see the ludicrousy of something, or you should just say, you don't think, you know, contriving an explanation is good enough. That explaining a force by just saying it just isn't saying anything, isn't good enough. That physics needs to do better than that. To say, oh, it just is like it's being attracted, without explaining how it's possible that it can be migrated from position A to position B by some invisible entity, when, you know, invisible is our perceptual problem, but it's not an acceptable concession in actual reality. Like spontaneous. From our perception, things can seem spontaneous, but scientists, most scientists anyway, know that there is no such thing as spontaneous. It's only spontaneous to our perception, but there really is a chain of cause and effect, and it didn't happen spontaneously. It happened through the course of cause and effect. So when somebody says a force creates attraction, you have to explain attraction. And I'm just saying this explanation explains it. That it's the substance of the universe is all just a bunch of moving billiard balls. They condensate into something called matter, and then the little balls keep bouncing into that matter and causing it to do things mechanically and create manifestations that we call forces. But those forces are just changing the balls through interaction from being this way to being that way, and depending on that shape, the effect is different on the thing it hits, like the Polaroid film. Different effect, different shape. Alright, enough said. So till the next video. But anyway, I'm just saying that when you make your videos, I just wish you would just say, I don't like this, I like this. That sounds reasonable, that sounds unreasonable. Because frankly, sometimes I don't know what side you're on. Because your rhetorical questions are not rhetorical enough. Alright, anyway, until next time.